All right, what is the relationship between the apparent size of the object when positioned behind the mirror at the apparent location of the image and the size of the reflected image? So this is a little easier to do when you actually get to it. But basically what it's saying is how big does stuff appear in the mirror compared to how big it is in real life? So if we move stuff around and all that, it goes, you see it in the mirror, right? So when this light comes in here, it bounces off here, but the light appears to continue straight back through here. So if it's a flat mirror, it's going to appear the same size. Now, you've probably experienced life when you look at the back of a spoon or something and you see the image inside the spoon. And if it's a convex mirror, it's going to then appear smaller. And if it's concave, it's going to stretch that out as it goes back through there. We're not going to worry about curved mirrors a whole lot. Fun houses and stuff like that do, but we're really just worrying about flat mirrors and how stuff bounces off of those. We're not getting like real in depth with this or anything, but apparent size is going to be the same with a flat mirror. So a flat mirror is not going to do a whole lot for you if you're thinking like telescopes and magnifying glasses is refraction, not reflection. But anyway, formulate a statement that describes the direction that light reflects off of the mirror. The light reflects off of the mirror at the same angle that it bounces in at, but I guess past. Now, how would we want to say that? That's an awkward sentence. The angle of incidence equals the angle of reflection, but it's reflected on the opposite side of the normal. That's what we should say something to the effect of the opposite side of the normal when I finish not being able to speak there, right? So you should say angle of incidence and angle of reflection are the same, but they are on the opposite sides of the normal, right? And then the last one there, what is the minimum height that a flat mirror must be in order for a person to see his or her feet when the mirror stands vertically? So if I want to see my feet, this is one students always get wrong. Students are always going to say it needs to be the same size because the size of the object is the same, but it is a virtual image. So if we imagine me standing here, right? When I look at, and we're just going to say your eyes are basically at the top of your head, right? Not too far off. So when I look forward, those light rays are going to bounce off here and then come back. Now, you're not shooting lasers out of your eyes, right? It's just light reflecting off of things. But what I'm going to see is here, and so that's going to reflect back to the same height here, right? When I want to look at, let's say, my belt, so if I want to look at my belt, I need to look at a point halfway between me and my belt. So it's going to be like that. That's going to reflect back. It's going to make the same size objects. My belt's still going to be in the same spot. I'm apparently very long torsoed, but it's but I'm only looking a quarter of the way down. So if I want to see my feet, then I need to look at halfway down. And again, it's going to put my feet clear down here, kind of thing. You look where where it would connect through to the feet, but the mirror only now has to be half the size. You don't need a full-size mirror to see all of yourself in the mirror because that mirror light can pass through clear down to here. And that seems crazy that you can see a 6-foot person in a 3-foot mirror, but you can't. And they're not scrunched because you're looking, there's depth into the mirror. So those light rays continue on and your brain is actually what's forming that image, not the mirror. And it doesn't matter how close or how far you get. If you back up, it's just going to be shallower angles everywhere, and it's going to form the image further back here, but it's still going to be half the size. If you get up real close, it's the same thing. Now, experience might mess with you a little bit here because sinks have a mirror that go almost halfway down. And you're like, well, I can't see my feet there. Yeah, there's the sink in the way, right? So if you were to find a mirror that is like this and there's nothing in front of it so that the light can bounce off from your shoes and get there, then you would be able to experience that. Anyway, go ahead and watch the Physics Girl video. She does a great job of explaining why when you look at stuff in the mirror, does it appear to flip it, right? Because, like they write the word ambulance backwards on the ambulance. So when you see it in your rearview mirror, you see the word ambulance and not the backwards of the word ambulance. So she does a great job of explaining how it is that stuff is flipped horizontally and all that kind of stuff. Not a lot of quiz questions or anything on that today, but still watch that. It's a really cool video.